Hey guys, welcome back to Chapter 14, Lecture 2 on climate alteration and global change. Let's go ahead and check out the objectives we're going to look at today. So last time we talked about just the general definitions of global change and what that is, the difference between that and global warming. And we really focused on the greenhouse gases, where they come from, how they affect our environment. Today we're going to specifically talk about CO2 concentrations and how those have been changing over time, some of the data that shows us that, and then focus that into this idea of a feedback loop. How is that making this process even more um, intense? So let's start with the first key idea. Number three, changes in CO2 and global temperatures have been linked. So there's been this linkage for a long time between how ups and downs in CO2 can relate to ups and downs in global temperatures. So this is data taken from the year 1958 up to about 2009, 2010. And I have another one, a graph after this. And overall, the trend, this is CO2 in the atmosphere, parts per million, has been this pretty obvious linear trend since 1960 to 2010. And notice there's monthly averages. There are natural swings in CO2 concentrations. You can imagine during the springtime when all the plants are blooming, they are taking in a lot of CO2. So there's always going to be seasonal upswings and downswings in the concentration. But overall, we see this large trend upward. I went out and looked from NASA's website and some other websites and trying to figure out where we're at right now. So if we were about, oh, that's hard to say. If this scale is still by 20, maybe about 400 back in 2010, we are up to 413 now, according to this data from March 20th, 2020. So still on that upward trend. This is from year 2007 up to 2019. So notice, oh yeah, here's about 2010. So actually about 390-ish. And we see continually upward in the same kind of linear fashion. So we've been thinking about CO2 for quite a while, and that's important because we talked about it's a very important greenhouse gas and that can affect the global temperatures. In terms of the actual global temperatures since 1880, 1890, we have natural fluctuations again. Look at from 1890 to 1910, and then we start to see some jumping and then some back down again. It leveled off. And then pretty stark increase is what we're seeing since the 1970s on. So this really stark increase in the temperature anomaly. So it increased about zero point 0.8 degrees Celsius. And actually, I looked up the current data. So from 2010 on, we see another sharp jump. So now we are almost to a degree Celsius versus normal. And that might sound like a small amount, but in terms of the global temperature, that is a large amount of energy all around us, packed into the atmosphere and the water and the land and everything like that. So where are these emissions coming from? So if we're thinking about CO2 and how they're increasing, we have millions of metric tons. So total, China is producing the most according to this data set. United States is not very far behind. So we are the big leaders in CO2 emissions by far. Per capita, so adjusted for our population, Australia actually does produce a lot considering its population, but United States is not very far behind. Notice China, relative to its really high population, is way below all these other countries. So in total, yeah, they are the king, but per capita, they're way down here. United States is almost as much as China in total, and we are second highest per capita. So US bears a lot of responsibility right now for how much CO2 is being put into the atmosphere. You might be thinking, what are some other things that might affect temperature? The sun, it could be, the solar irradiance, the amount of energy coming out of the sun does fluctuate. And we have these averages right here. This is the yearly total irradiance, and you can see fluctuations. The line is showing the 11-year average. So the 11-year average kind of smooths it out and tries and kind of helps correct for some of the noise, as we call it, in data sets of those fluctuations. So we do see some fluctuations and we see some slight increases here. We see though over the 11-year averages, it's leveled off since the 1960s, but we still see this significant increase in the global temperature. So it doesn't look like it's the sun, irradiance energy that's actually keep pushing up this increase in our temperature in the world. Also, interesting to point out that the temperature increase relative to what it was in years past is not equal throughout the world. So this is showing us that actually it's actually been cooler through 1951 and 1980 than in the southern part of this hemisphere here, but look at the northern part. It's really highly concentrated in the northern sea caps and Greenland, things like that. So it's affecting the world not the same in different regions. So that also can cause problems. There's a lot of disparity between who's affected by these temperature changes and who's not so much. So how do we actually figure out the past? Well, we have these, they throw these big years out. Again, I'm a Christian and I believe in a young earth. But what they do are take these really long samples of ice and they can measure, there's every time a layer of ice packs down, it can trap some of what basically a little time capsule of what was going on in the atmosphere. So they do chemical analysis of the ice to figure out what was in that ice. So the farther down you go, the older the ice is. Now there's different theories for how old the Earth is. So depending on what your theory is, one of these centimeters or millimeters of ice could represent a lot more years of time. I don't agree with the amount of years that this data comes up with, but I do agree with the relative reasoning here. The fact that as you do go down lower, you can kind of go back in time and see how CO2 composition was in the past. So what they're seeing, and this is their timeline, these scientists believe the timeline, if this is current level, and they're going back hundreds of thousands of years, these are the CO2 parts per million that they're measuring, and they see basically these spikes that come up and down over time, natural spikes in the CO2 levels, but then this insanely high spike that they've never seen. The highest it's been in their timeline is right at about here at 290, let's see, maybe 285, something like that. And we eclipsed that way back in, I don't even remember. Let's see, is 280 even part of our CO2 graph? No, 280 would have been way down here back in the 1900s. Who knows where that was? So something's happening, and we're trying to figure out why. So for me as a young Earth scientist, I would believe that this is relatively correct, but I would change these numbers to smaller numbers. So I do believe that we're seeing something unprecedented, even though I don't believe in these long timelines. This is still very significant. Why are we this high all of a sudden? This does not look like kind of a natural kind of change in the CO2 concentrations, even though we know we do see seasonal and long-term differences over time. So this is another zooming in. So this is if we zoom in, here's the timeline, time years before present. This is carbon dioxide again. We have this relatively, fluctuating, and then this rise here, and then this. This is what we're actually looking at. Before the 1800s on, this is that small portion. This is the unprecedented rise in CO2. And notice we have also unprecedented rises in methane and unprecedented rises in nitrous oxide. All of these things that we talked about in the previous sections of our anthropogenic sources, farming, agriculture, combustion, all this stuff that's gone into these really high increases in human-made increases in greenhouse gases. So now that we've kind of looked at some of these trends, what's the big picture of this idea of increasing greenhouse gases and CO2? We kind of we're understanding that we're seeing this really convincing correlation between global temperature and greenhouse emissions. So what we like to discuss is in terms of, sure, that could happen, and that could happen naturally. So, but what if we think of this in terms of a feedback loop? So we know an increase in CO2 level causes greater capacity for global warming through that greenhouse effect. And what else happens then? So when we actually increase the global temperatures, the oceans become warmer. Now, what happens when the oceans become warmer? Think about room temperature soda versus cold soda. Soda has dissolved CO2 in it, and there's only a specific capacity for CO2 that can be dissolved in water. It depends on temperature. If you heat up the carbonated soda, it's going to foam pretty easily. It's going to foam more. So as the ocean is warmed, it's also doing that same thing. It's releasing CO2 into the atmosphere that's already been dissolved in it. So if we warm the ocean, it's going to release even more CO2. So this is a cyclical effect. This is a feedback loop. So warmer Earth causes the ocean to release CO2. Then higher CO2 concentrations in the atmosphere warm the Earth even more through the greenhouse effect. Then that warming causes the ocean to release even more CO2 and back and forth, back and forth. This is a closed loop. Sorry, this is oh, where's I lost my feedback loop slide. Well, that's sad. I'll make sure to get that feedback loop slide in the next section. But this feedback loop is pretty powerful. So this is the last kind of part of our discussion for this short lecture today. This feedback loop feeds into itself over and over and over again and amplifies the effect of global warming. That's really the tough issue with global warming. It's not just a process by which we warm the globe a little bit. We warm the globe and then we get more CO2 because of our natural sources that we have in the oceans. So it becomes a bigger problem. So let's go back to here. So again, we've talked about what global climate change is. We see that there's a lot of sources of greenhouse gases that affect the planet. We have a lot of data showing these things, and we can understand this feedback loop that's happening. Next time, we're going to actually look at the global effects. So what is the actual practical reasons why we do not want an increase in greenhouse gases, and we do not want an increase in global warming? So we're going to talk a lot about that in the next 5, and then a little bit about what we've been doing as a society to help reduce global warming. So enjoy this short video today, and I'll see you guys on Monday for the last section of this chapter.